So just for everybody to know that we're going to record this meeting as well, but at the end we're going to, if it's requested, we can eliminate your names on it. So just give us a message that you don't want to have your names on it, and then we're gonna eliminate the names, because we want to share this video, this recording also to people who cannot be there, and we want to, well, just inform them, just sharing the knowledge in our website. Okay, so now that we are more people, I would like to start. So good evening, everyone. I am super excited to welcome all of you to the first meetup of our data technology community. And as we gather here today, so I am reminded of my personal journey and how it led me to create this meetup, this community. More than 10 years ago, when I was in the university in a small town of Germany, I learned a lot from my professors and from the students, from my peers, but I always felt like there was something missing. I was really asking for a community of like-minded individuals who share the passion and for data and technology. Especially, I was so interested in data science, but beside my students, I could not talk to many people because my network was so small. And many years passed, I found myself working in the tech industry. I was a consultant for many years. I learned, I grow. I created my own company about 2 years ago, which is specialized in DevOps and AI and cloud. But I still have the feeling that I would like to have a community of like-minded people, and not just in a certain area, but especially I would like to discuss the tech topics with people located in Asia, in America, Europe, Africa, all over the world. And then one day I remember the words of two great innovators who left an incredible mark in our world, Steve Jobs and Thomas Edison. So Steve Jobs is my personal idol. And Steve Jobs said a lot of things, but he once said, innovation distinguishes between leaders and followers. And this sentiment captures the essence of what we hope to achieve in this community. We want to be the leaders in the field, what we are doing right now. We want to push the boundaries of what is possible. So we want to have the community speaking with each other, sharing ideas, seeing what is possible and push it further. And we also want to inspire the others to do the same. And well, similar to that, Thomas Edison, he said, I have not failed. I just found 10,000 ways that won't work. And this quote explains the spirit of experimentation and dedication that we hope to advance within our community. And we encourage everybody here to tell each other about success, but also about failures, because we believe that every failure is an opportunity to learn and grow. So that's why I would like to, for the speakers, also for the participants here, in every of the meetup, we're going to have 2 speakers, and then we're going to have some discussion after that. I would like everybody to speak not just about the success, not just about the beautiful things, but also about the experience in the project, what went wrong, what didn't work, and what we wish we would have done differently if we had the chance to do it again. Yeah? And this is why we are here today. So we want to create a community of learners, innovators, and leaders. We can come together, share the knowledge. And our goal, I mean, my goal, and also the goal of the people, of the organizers here, is to make the information about data, about technologies, accessible to everyone with an internet connection. Because I know that there are a lot of meetups out there, especially in developed countries, like industry countries. In Germany, there are a lot of them. In America, there are so many of the meetups about technologies. But how about these underdeveloped countries? How about the countries which doesn't have this kind of community in their place? So that's why I believe that knowledge and education should be accessible to anyone, and it should not just be a privilege of the big industry countries. And I believe that this concept is bad, so that we should have the community extended. We should make this kind of information available to everybody. That's why I would like these meetup series. This is the first time we do it. I would like to have these meetup series be online, and I would like to make the talk, the discussion we have here, available to everybody in the world, not just for the privilege of the big industry countries, but also to make it available to everybody who are hungry for knowledge. So in the closing, I would like us to remind ourselves the stories about Steve Jobs and about Edison, the spirit of innovation, the spirit about accepting the failures, accepting that there are things which can go wrong, to be vulnerable, to be speaking about things which didn't work in the project, which work in the project, so that we all can benefit from it. So we all can learn from the experiences in the project the speaker talked about, but also from the discussion between us. So here's the format for the speakers. Usually we're gonna have the event on the first Wednesday of every month. And we're gonna have the whole events, like I said, online. It's gonna be recorded and uploaded into our website, so everybody can see it, everybody can just have a knowledge to this, or just have access to this knowledge. And now I would also want to make a call for speakers. So it doesn't matter if you're in Germany, in Europe, or if you are in, I don't know, Asia, Vietnam, or if you are in America. We are looking for speaker regarding the topics of AI, regarding the topics of machine learning, of cloud technologies, quantum computing. So as long as it's something very interesting, and we want to emphasize the project experience, because I think this is what we're most interested about, right? I mean, technologies are the same, but I think the particular experience in each of the project is always different. And I think we can all benefit from it. So we're gonna have 20 minutes of talk, maximum 20 minutes, right? So between 15 and 20 minutes of talk. And then we have 5 minutes of Q&A. So after the talk, everybody is welcome to open the camera if you want. You can also ask any questions to the speakers if there's something not clear. And at the end of the two talks, we're gonna make a breakout session. So every speaker will be in one breakout room. And then the participants, you can go to each of the room and you can ask questions. Okay. Yeah, so that's all from my side for the opening. And right now, I would like to jump right into the next session, which is the speech. And well, because I mean, I am a software developer myself, and I would like to also start. I have the honor, let's say, to start the first talk of the meetup. I'm super excited to do that as well. So now I'm going to share my screen. Okay. Hua, can you give me a thumb up if you can see my screen? Very good. Then I'm going to start. Okay, let me keep this here. Yeah, so like I talked to you before, I started as an IT consultant. I do different things. I do software development. I do AI a little bit. And I quit my job about 2 years ago and created the company Datix. So the company Datix, first, we specialize in building data platform. So the typical case is the customer come to us, ask us, hey, we have data, we have pictures, video, we want to do machine learning, how to start. And we're gonna support them setting up this infrastructure from the beginning. It was not always this way. So in the beginning, when I started as a one-man show, I was trying to do different things. I say we do AI, cloud, DevOps, but over time and time, we after the first time we setting up a data platform, we are more and more recognized for this kind of project, and now we have developed a 5-step process how to create a data platform. So in this talk, I'm going to talk about how we set up a data platform as an accelerator for doing machine learning. I will speak about our 5-step approach, how we successfully set it up in the first place. And I'm going to speak also about the things which didn't work for us, which went wrong currently, like which really went wrong. And I will also tell you guys about what went right, so you can also apply some of the concept into your projects. And the project I want to talk about today is a customer project about the healthcare sector. So you know that in Germany, we have a very big issues of data privacy, and this is the healthcare issue. This is the healthcare sector, but later I'm going to talk more about the data privacy issue. And the situation or the problem of the customer we have is the customer is a very big manufacturer for creating medical devices. So in the past, it was quite good, and now because of the whole technologies, so now we have AI technologies, we have cloud, we have so many different technologies. My customer is fearing the competition coming from America or from China, because now they have the access. I mean, building a machine was more difficult, I would say more difficult in the past, but now it's getting much easier, and the knowledge transfer between the sector is there. So it's not so difficult to build a machine anymore to create a medical device. And if you want to stay competitive, you have to offer additional service on top of the medical device. And this is one of the motivation my clients say, hey, we really have to innovate. We really have to do some machine learning. We have to see what machine learning can enable us to do. So actually the client, they don't have, or now they have, but back there 2 years ago, when I started the project, they taught me, hey, we don't even know what we want to do with machine learning. We have no use cases, but we know that we have to do something. So at least now, well, they know they have to do something, right? They know they have to innovate. They know they have to create some machine learning use cases, but they don't know what to do yet. So that's why the first step they taught me is, well, how to start, how to prepare our company so that we can be able, so that we are able to build machine learning use cases in an easier way. So the situation is like baking a cake, right? If you want to bake a cake, you need to have the cake board, you have to have an oven, and similar, in order to do machine learning, you need to build a stable data platform. So the data platform is like an oven. The data are like the materials for doing the cake, and the result is like the cake. So this is the machine learning is like the cake, in order to visualize the whole things. Yeah, so it was, like I said, it was the first project we did in the company, and back there I was one-man show, and with my background in software development and machine learning, so I seem to be a good candidate for the job. This is what they thought. But I was so scared there. Man, I was so scared because 2 years ago, it was new water for me. I didn't really know what I was doing, to be honest. So I know that I want to create a company. I want to be self-employed, but everything was like new to me. So I never do a project by my own. So usually when I do a project, I have like my team, you know, I have software developer, I have my project manager who is speaking with the client. And usually I would be either the data engineer doing the data pipeline, or I would be the data scientist who play with data, mathematical models. But I was never someone who do everything, who do the whole pipeline. So it was quite scary for me, the whole thing. So I thought, should I decline it because I didn't have the knowledge yet? It was not an option for me. So I mean, no, it's just not an option for me. So at the same time, I was so excited to create something new, to create some value for the client, for the customer, and also for the main guy. I was like, yes, now is the time for me to shine. I can really do something very great by my own, not having to work for my boss. And it's a chance it was for me a chance for me to prove that I can do better than I thought. It was more for me. At this time, I was like, yes, I can do it. I can bring value to the customer. I can help them. I can support them to order to digitalize the company. So I was really motivated to actually help this middle-sized company, this little German middle-sized company, to innovate and to beat the competition in China, in USA. So it was my motivation. That's why the first thing I did was I called all of my friends. I speak with people I know who are expert in certain topics. And the funny thing is, the moment I speak to people, they are like, "Whoa, this is really good what you're doing. So I want to work with you." So this is how I slowly built my team. I slowly built my team in just by talking to people. So this is for me the first lesson learned. When I encounter a new topic and I know that I'm lacking some skills, speak with people, and the people will tell you what to do. They will support you, and many will even want to join you. So this is also the case. So this is how I get my first employees. They say like, "Wow, this is really good what you're doing. I want to be on board with you. I'm gonna support you in this." Because they know that this is a new topic. This is a topic we want to digitalize the whole company from scratch, and we start everything from scratch. So it was actually quite exciting for many people. Yeah, so now I would like to speak a little bit. So I would like to speak a little bit about the approach. So you see here on the left side, we have the client. They have different amount of data, huge amount of data in different formats. And they have pictures, they have videos, they have sensor data. They have also hardware, data for the hardware coming in. And they want to, so the first step would be to create a centralized place where to store all of this data. So this is the first step ever. We decided to go for Azure back there because it was just easy. So because of Microsoft Office, the client, they already have Azure. They already have the account there. So the setting up was easier. And then we have to have some kind of place where people can upload data. So we create a web upload data. So we need to have a kind of a web upload data where people, every local user with a machine sitting in the hospital or wherever can upload data from their local machine. And the next step, we say that once we have the place to upload data, we have the data storage to store data. Then we need a machine learning workbench in order for the data scientists to do machine learning. So we say, hey, a data scientist, we assume, we make the assumption that data scientists just don't like the job of building the infrastructure and of dealing with the data engineering and so on. They just want to do mathematical modeling. So that's why we create a space where the data scientists can do the machine learning. So they don't have to care about any other topics not related to machine learning, to mathematical models. Yeah, so in order to build it, we use a step-by-step approach, a 5-step approach. I'm gonna go to in a very high level so everybody can follow. the approach is a little bit more complicated, but I would like to make it very short so that you guys know what is what we did there. So the first step is visioning. The first two steps, visioning and personification. These are the steps we talk about problems with the customer. So we have a question catalog. We ask the customer first about the problems, about what is actually their pain point. We speak about what are the end users, because our customer is actually not the end user, right? So the end user can be different. The end user can be somebody from the hospital who upload some data into the platform. The end customer can also be a data scientist who work with this data. So these are actually our two customers. And we have to really vision this kind of customer. We have to create a customer journey to really understand the business behind this topic, because I see that many times that a company, a consultancy company, go into the project and they just want to do, I don't know, fancy machine learning. They want to do fancy technical approach, but they forget the big picture. So I think, from my opinion, the big picture, the problem space is very important. So we ask them a lot of questions. What kind of data they have? What are the amount of data they have? Like, are we speaking about 1 kilobyte? We speak about 1 terabyte, or we speak about petabyte? Then we also asking about the timeline of the project. So what are the timeline when we should finish what milestone? We also speak a lot about the stakeholders. So who are the stakeholders in the company and what do they expect? Because sometimes stakeholders can be so different, right? They might be people who give the budget. There might be people who access the success of the project. So the first two, we speak about the problems. And then once we know about the problems, we speak about design the data architecture. So we speak more about this documentation, right? So we make a solution architect. We say like, okay, here we need one component, here we need an upload tool, a data storage, we need a machine learning workbench, and so on and so on, depending on what we know from the first two steps. And the next step is going to be setting up the system. So it's going to be straightforward, right? Usually we do set up the data storage, we set up the web upload tool. It's all standardized. So for every new project, we don't have to customize too much. And sometimes if we see the use case doesn't vary so much from each other, there are infrastructure as code, there are Terraform, you can just do a few clicks and you can set the whole infrastructure in the best case, like a few hours. Then when everything is setting up, we make a demo, show the customer, and make a training, and then we do the handover. So pretty straightforward. Yeah, so I don't have a time to go very deeply into one of this topic, and I see that my time is running up as well. So I can show you like one of the steps or one of the things we did was comparing the cost between Azure Cloud and on-prem, because sometimes, especially for a customer who are a little bit more old school on the way, they say, hey, we don't want to do on-prem on the cloud. It's so insecure. We hear that it's insecure, it's from America and so on. And then we make a comparison between Azure Cloud and on-prem and show them the cost, the technical involvement, and the security. And we tell them that, hey, even for security, if you have the data on-prem in your own server, it can also be insecure, right? I mean, having just the data on your server doesn't mean that it's going to be secure. So you have to really think about it and also convince or speak with the client what is the best case. Yeah, so I'm going to skip a little bit and a little bit about the architecture overview here. So like I said, we have a data storage on the bottom right. We have a data storage where we store all data. We have here, you see an upload platform in the right top. The top right, this is the place where which we use to upload data from the local machine. Then we have the machine learning service workspace, which is on the bottom in the middle. So this is the space where the data scientists can use to do machine learning. So like I said, we don't do machine learning here, but we create a platform, we create an infrastructure so that the data scientists can really concentrate on just doing this doing the machine learning job. Yeah, and now I would like to speak also about the lesson learned. So we recognize that first, data privacy for AI project is a big topic and it stays a big issue for the customer. So I would like to emphasize something. You have to advise the client to take care of it from the beginning, from the very beginning, because data privacy is a very big issue, especially in Germany. So I'm not sure about these the other countries. I would really like to have more insight into that, about how, I don't know, how America or how Asia handle this kind of issues. But here in Germany, it's a huge issue, and so at least now we've been together with the client for 2 years, and now after like 1.5 years, the client say like, hey, we have some issues with the data privacy, and maybe we have to really think about everything, right? So they are thinking about going back to the on-prem, to the server, or maybe just do a hybrid. So these are things which need to be considered in a very early stage of the project. It's an ugly topic, but I would recommend everybody to really take a look into that, because this is not the first AI project where data privacy is an issue. So I know that from my previous project in a big automotive company in Bavaria, in south of Germany, we have the same issue, that we don't have the access to the data because of data privacy issues. So in Germany, I speak also with many people who are in the sector of machine learning, and there's a saying: if you are working in a big company, you want to do machine learning, and then you need to have approval from the lawyer, from your law department. Usually the people from the law department will say, hey, you know what, you can never achieve 100% security for data privacy. So there's always like 0.1% of risk for data privacy. And well, many people just don't want to be associated with the bad news, right? So they rather do nothing than to be involved with these kind of issues, with this kind of data privacy issues. So that's why you don't see so much of innovation about AI in Germany than in other countries, from my point of view. I think it's very bad, because then if we don't do that, then the other countries will just take over Germany and be a leading in AI. And I see that there's so much potential in Germany regarding AI. We have a very strong manufacturing sector here. So I think we should really invest more, and we should really care more about this topic. But data privacy stay a topic at the beginning of the AI projects. So the good thing is, I see that rapid prototyping with increments, it proves to be a very good method. And the thing is, so when I came into the project with a team, so when we first support the customer, I think in around 1 or 2 months, we were finished with the whole pipeline, end-to-end pipeline. And with this pipeline, the client went to the management. So our customer went to his boss and present the whole thing. And the boss was like, wow, you guys did a very good job in this amount of time. So this is the way how we really can get more budget and more attention for the project. So on the one hand, data privacy is an issue for the beginning of the project, but on the other hand, I would advise not to wait for too long and just start to do rapid prototyping, so that you can have some attention from the management, and at least the management can see something, right? So always make it so visible that they can click and they can upload data by themselves, and then they see like, okay, there's a value in there, this is getting serious. This is how we got so much of attention. All right, so my time is up. Thanks a lot for being here. And I'm gonna be, so now we have about, I would say like 4 or 5 minutes of Q&A. I would answer like four questions, let's say 4 questions. And at the end of the second talk, we're gonna make a breakout room so people can, you can ask me some more questions. Yep, thank you. All right, so now is the time for questions. Yep, so if you want to have some questions, just unmute yourself and just say it. Yeah, I think Javier has a question.
Hi, my name is Javier. I'm in Miami. Thank you for the presentation. So the question I have in terms of some of the AI projects that you're mentioning, do you see more of a need from customers who more conservative customers, like they have like a lot of on-prem services? Do you see more of a request from them than others who are like, say, who don't? And if it does, is it a specific type of AI project?
Yeah, so I see right now, I see a lot of requests from middle-sized companies who are more conservative, right? Because the companies which are less conservative, they actually have already built something by themselves. Big companies like Siemens, I say in Germany, Siemens, Volkswagen, Audi, BMW, they all build their own infrastructure. So they already have something in place. But the middle-sized, the conservative companies, like middle-sized companies, they are starting to do it. And because now they are starting to do it, it's so much easier to start everything from scratch. And this is, I think, the biggest advantage to support this kind of conservative companies, because now they say, okay, wow, AI is huge potential and we have to catch up.
Got it. Thank you.
Yeah, thanks. Good question. All right. Anyone else? Okay, if there's no more questions, then I mean, at the end, after the talk, the second talk, we're gonna have some time in a breakout session so we can just discuss as well. Yeah. And now I would like to hand over to Hua. The stage is yours.
All right, thank you very much. I'm also feel honored to be here to join the session and also to talk a little bit about what I do, who am I, and thanks for the invite. So I think you can see my presentation. I will directly start now. So my name is Dang Hua. I'm a freelance data scientist and also a medical doctor. I'm in Berlin based and also a doctoral researcher at the Charité. And today I would like to talk about sepsis, a disease that is very common and quite serious in German hospitals. So in the next few minutes, or for this talk, I would like to talk about the sepsis, why it's relevant. Also talk about how research in this field is right now, what the aim of our research project is, and also have in mind what the challenges is when you work with healthcare data. And at the end, I will also talk a little bit about training and evaluation. So basically what we want to do is we want to build models that can predict sepsis, to put it in a nutshell. Okay, so what is sepsis? Sepsis is a life-threatening condition which results from a dysregulated response to an infection. So basically, there's an infection and the body overreacts and does too much to combat this disease, which causes organ dysfunction and organ damage. And the mortality is quite high. So about 11 to 43% of people with sepsis will die. And if they have, and if there is also a septic shock, the mortality goes up to 61%. And it's the third most common cause of death after cardiovascular diseases like stroke or heart attack and tumors. And also sepsis, with sepsis, there's an increased risk for secondary disorders. And also there are studies that have shown that for every hour of delayed application of the treatment, which in this case is antibiotics, there's a increase of more than 7% in mortality. So this is pretty serious. And early recognition of sepsis can prevent a bad outcome and improve in the long term how a patient is. So we have looked at many studies, and there are a ton of studies on this topic. Many studies explain that algorithms, machine learning algorithms, have the potential to predict this disease. The problem is all the studies are very heterogeneous, and the quality is also very different. It also means that even though we have many studies, we have very little code to replicate what has been done. Another point that is also very important but often neglected is very concrete example on how data was extracted, how data was pre-processed, how it got validated, because the data is the basis for every machine learning model. And if we don't know how the data was pre-processed, it's very hard to really say if this model is good or bad. Another thing we have seen that most of the time there's a public medical data set from intensive care units from the States. It's called MIMIC. And this data set is used very often, but there are very little studies that have been applied on German data. And also what is also very important when we talk about machine learning in medicine is that the model that we develop has to be explainable. The physicians have to be able to say, okay, we have an increased risk for sepsis due to 1, 2, 3, 4, 5. And this is something that we need to address in our work. So the objective of this research is to have a model that is based on data which got extracted and validated, and were extracted in a pipeline that is very strict, where we really made sure that the data that we use is correct. Also, we want to make sure that the model that we use can be applied to German data. So we are trying to apply models to German data. And we also want to make the models explainable. So what we do is basically, we have looked into the current research, and we want to build models that are that piggyback basically on current research, and also take the already present knowledge, and we will take this knowledge to make models, to try to create models or apply models and make them even better. Okay, so in the following, I will talk a little bit about the pre-processing process in healthcare data and what the challenges are. So this is the patient management system in the intensive care unit. It's called COPRA. And this is how it looks like. So you see many curves, which are for temperature, heart rate, and other important information. But what you can see, it's kind of looks old. It's not very neat, and it's very slow. So if you're used to modern applications, this is something that surprised me how it's being used, and how slow it is at the end. Because if you scroll, instead of, you would think you scroll through a page, but basically every time you scroll, I think, if I understood correctly, the whole data gets loaded again. So if you do 2 scrolls, it's like 2 times loading of the data, which makes it incredibly slow. So for the pre-processing, we looked at the past 15 to 20 years. We extracted about 60,000 patients. We have over 180 million data points. And the first step was we wrote an extraction pipeline, and then we tried to see that the data that we extracted is actually the data that you can see in this front end. And this is a very tedious work, because for every variable you have to look the data up and to see if it's correct, and then you have to move to the next feature. In the pre-processing pipeline, we also harmonize the units and names of the same variables. We remove outliers, and we also remove data during surgery, because if patients are in a surgery, it's an environment that's where the physiology of the human body is a little bit altered, because they are ventilated, and this is not the regular way, or if you look at the data, it's not the normal evolution like it would be in the intensive care unit. On the right, what we see is just an example for a drug called norepinephrine, and the unit where it's actually applied is microgram per kilogram body weight per minute. But you can see that in the database, we have a ton of different units. And for every unit, we had to look into the data and to see, okay, does this data make sense or not? Can we converge somehow, or do we have to remove the data? I also want to talk about labeling the data a little bit. So we have a suspicion. So sepsis can be defined as 2 things. You have a suspicion of infection and a score that has to be positive. Or to be exact, you have a score, and this is a numeric score, and this score needs to be increased by 2 points, as well with the presence of a suspicion of infection to fulfill these criteria. So real quick, suspicion of infection is present when there are 2 things. If antibiotics have been applied, and if there has been a fluid sample. A fluid sample is, for example, if you draw blood to determine if there's a bacteria in the blood. So if you have those 2 things, the suspicion of infection is present. And if you have the SOFA score, which is a score for the organs, if that score is also positive, then you will have sepsis. So the problem, for example, at the Charité and also other data sets were that there is that we did not have any information in the system for the blood culture, for example. It does exist in the system somewhere, but it's not accessible right now for extraction. So we had to come up with a different way to combat this idea. So we said that a suspicion of infection is if the antibiotics have been applied for 3 straight days. And we did some tests and plots to see if the cohorts make sense or not. And it turned out to be a decent proxy for suspicion of infection. So we have pre-processed the data now. We have labeled the data now. Now I want to talk a little bit about implementing and training the models. So here's a table with different models that have been used in research. Our idea was to take models or description of models which already performed nicely or decently, and take these models that were trained on this mimic US data set, and we want to apply these models and also we want to apply these models to German data to see how they perform. So this was our idea. The problem here is that the code is not often available, and sometimes only fragments are available, or the code is available, but the final model is not, the final trained model is not available. So what we had to do is to reconstruct the models and also tweak things that we thought were necessary. For example, improve some pre-processing where we think, okay, this pre-processing doesn't make very sense, so we will try to do something else. So we try to implement those models, and also during that implementation we also put our own improvements on it. So I will talk the following about 2 models: a logistic regression, a very baseline model that is always needed to see how the other models perform, and a neural network, a temporal convolutional network. So we have a logistic regression, and this logistic regression had 59 variables that were measured, for example, heart rate, blood pressure, temperature. We also have scores. We also have static data like age, weight. And then there are also variables which indicate if for this hour the data was present or not. If for a certain hour there was information, for example, on the heart rate. And because we have a logistic regression, and logistic regression in nature do not necessarily have the ability to compare different data points and to respect the temporal dimension, we also calculated look-back statistics, for example, the highest blood pressure, systolic blood pressure in the past 6 hours, in the past 12 hours, and so on. And here are some hyper parameters. We realized that after testing that if you use the default settings, which is a L2 penalty, and also use class weight balance, which is important because this is an imbalanced data set, the logistic regression works pretty well. Here I just want to show you the results. Basically, this is a curve. It's area under the receiver operating curve, and basically the higher this number is, the better the model is. So there's a blue line, which is a little bit hard to see, but this is basically the training data. Then you have the 2 more lines for validation and test data, and then you also have the red line is the testing data, the German Charité data, and you can see that it performs quite well. It's close to the performance of the training data, and we also have a very specific evaluation strategy. which also has been used in literature, for example, by Michael Moore. And this evaluation strategy basically makes one label per patient to evaluate on. So at the end of the day, you don't take all of the times and this labels for every hour and calculate the whole area under the curve, but you take one label per patient, and from that you can calculate the true positives, true negatives, false positives, false negatives, depending on what metric you need. So we also did the same thing for the convolutional network, and it also has a decent performance. Regarding the features, we did not need any look-back statistics because temporal or TCNs can consider the temporal, the time information. Here, I just want to show you that, okay, we have this model right here. So it's the Charité logistic regression. Now we want to know how the model performs. And we use something like shape values. We calculated the shape values for the logistic regression for the training and testing data. You would expect that the feature importance is the same in both data sets because we have normalized, we have harmonized the data. You would expect the features to be the same. But what you can see here that the features are not the same. For example, this means the mean diastolic blood pressure of the last 16 hours. And this is a feature which counts the amount of data of lactate in the past 16 hours. So you can see that there is some differences which we didn't necessarily see when we only had that one area under the curve metric. So now we were like, okay, we see that this differs. So why does it differ? And if we plot the training data and the testing data for these variables, we can see that in the training data, the amount variable has, or the value of 0 is very common, whereas the value of 5 in this case is more common. And you also see the different distribution. So there's no wonder that that there is a different feature importance if the data of both data are different. So that led to the question, why is there still a difference in data set, even though we harmonized the data set, even though we looked at each raw or measured variable and tried to see if the ranges are normal, if the units are normal. But here in this case, we see that the frequency, the distribution is different. So we realized that there are differences in the data sets in the countries, even though the human being that was the patient has the same physiology. So this is where we are right now. We are looking at the data. We are thinking about how can we harmonize the data? How can we make everything look the same so that our models can work well? Do we have to change anything in the models so that we have a stability when it comes to different data sets? And what always is also important is that we look at the model and we determine if all the pre-processing and the evaluation we did is clinically meaningful, if it really does help the doctor. So this is just a short overview where we are right now. So to summarize, the pre-processing is very complex. We need to harmonize a lot of data, and we always have to go back to improve it. We have seen that even though the human physiology is the same, there is some differences in the hospital infrastructure, which might influence the outcome of the prediction. So our plan is to dive deep into the differences in the data sets in the hospital data to see where the differences are, how we can streamline everything, how we can harmonize the different the different distributions or values or ranges. And then we want to apply more models, see how they perform, and basically do the same thing. So basically we just try to see to make sure the model works well. And when one model is working well, we use another model and do the same process again to really make sure that the model predictions are meaningful. All right, I've come to an end, and thank you for listening. And if there are any questions, feel free to ask.
Thanks, Hua. I have a question first.
Yeah.
So you mentioned there was a huge amount of data, right? So you were working with this huge amount of data, and how did you, which kind of technology did you use to process this amount of data?
Yeah, so there are different things you have to consider. So when we work with the mimic data set, we can, if we work with the mimic data set, we can basically use BigQuery because it's hosted there. We can use BigQuery and all to do some to extract the data, and then we can. It depends on the workflow a little bit, but basically the data you get is from BigQuery, or you host it locally, which is about, I don't know, 50 to 100 or to 200 gigabytes. But when it comes to, and then you can pre-process everything with scripts. But when it comes to hospital data, it's a little bit, because of data privacy, everything has to stay in that hospital environment. So what we did was we basically wrote scripts so the data is hosted in one place, so it gets transferred to our to other analysis servers, high performance clusters, and there we have more scripts where we can run and then analyze the data. So basically, the data is hosted somewhere within the Charité data network, and then we have many ETL steps to extract the data, to transform the data, and to put it into a format where we can work with.
Okay, sounds very complicated.
Yeah.
But you did a lot of work there. Thanks.
Yeah, definitely.
Yeah, I think we have a question from Vasilena, right?
Yeah, hello, can you hear me?
Yeah.
Okay. Thank you very much for the presentation. It was very interesting and have very impressive background. I just missed that part because as long as I understood, don't we have like categorical problem because is sepsis is present, true or false?
Yes.
Why do we use regression?
Okay, so when we talk about logistic regression, it's called logistic regression, but it's basically a classifier. So if you look at the logistic regression, it's basically a linear model. So it's like mx plus bx plus something. So you have all those coefficients, which is a linear model. But because you want to make a classification problem out of it, you can you put this linear function that you have into another function, and that function basically maps the output to 0 or 1.
Mm-hmm. Yeah, okay. Thank you.
Okay, there's another question from Michael, I believe.
Hi, I do have a question regarding the data availability. So you mentioned that you are doing this mainly only based on the Charité data. I think that's one hospital. And you probably encounter some data privacy issues that you cannot access other hospital networks. So I'm just wondering if you are making a prediction model on sepsis, whether only having one hospital network's data is representative and whether that's enough to do that.
Yeah, so that's a valid point. So I talked about Mimic and the public data set. In fact, there are other public data sets that are available from, I think, from Switzerland, Amsterdam. So there are a few public data sets that you can work with. But when it comes to applying to German data right now, it's only done on the Charité data, which is true that it's only one hospital, but it's the largest in Europe. Yeah. And there are like 3 campuses and a ton of different intensive care units. But we're also thinking about maybe cooperating with other hospitals to try to use more data sets and to make the model more stable and to have the model be more representative.
And if you do include other hospitals or use international data, I can imagine that between the different hospitals, the data collected, the data fields could actually be different, right? So your input variables could also be different. So how would you deal with that?
Yes, so right now we already are applying a US-based model on German data. So, and then we will already see what the problems might be, where we can tweak things, and maybe what things we can adjust, or if the main predictors stay the same, or if they also change. But ultimately, when we apply the model to a different hospital, we will need to do the same thing to see if the model is stable or not, if we have to adjust something. So it's basically the same process maybe again, but because we have already done it, we can maybe reduce the amount of work that has to go into it.
Yeah, makes sense. And maybe a final question from my side is more macro view. Do you guys think that the data sharing limitations between hospitals and between patient data service providers is like one of the major hurdles for AI to be implemented in the healthcare setting? And I'm just wondering whether there's any, let's say, initiatives to make data sharing and data privacy issues in healthcare more friendly for promoting innovation.
Yes, so there's actually a lot of work in the background, and it's a very current debate. I think I read an article somewhere that that really addressed this problem, that if you share data, if you make it the right way, there is no problem with data privacy. But it's all right. Machine learning is about data sets. More data, the better. So there needs to be a way how to share data without violating any data privacy regulations. And I believe it's important. But what I also think is that within the hospital, when the data gets extracted, there needs to be a ton of people, data engineers, data scientists, whoever, that really can deal with the data, because even before it can be shared, there's so much going on when it comes to pre-processing the data, that even before you can share the data, there's so much work you have to do to make the data basically shareable and have a format that's useful.
Yeah, thank you.
Thank you. I don't know if we have the time, but I think someone raised his arm before.
Yeah, I mean, now we are a small group, so we have a time. I think we're just gonna stay here until 8:30, like 20 more minutes. And everybody has any questions, can just ask.
Okay, that's cool.
Yeah. I have another question. So, I mean, this is very promising, right? So when I hear about it, you do the prediction for sepsis, which is like a disease. And I think it's quite promising because, I mean, many years ago, we hear about cancer detection with what is this? Cancer detection in general.
Yeah.
But we don't actually see a lot of use cases. We don't see actually a lot of solutions in that. We see a lot of use cases, but no solutions.
Yeah.
What do you think is a problem in the medical sector?
So I think the problem is multifaceted. So one thing is, it's basically the same problem with big companies, right? Big companies are slow. Big companies have their workflows. Try to implement something new is very hard. When it comes to medical data, what is also very hard is there are so many different type of data coming together. Because if you have a company that's only based on let me call it digital data. So everything data that's already in the system, it's easier compared to medical data where you have the patient. So you plug the patient into a machine, or you put some sensors on the patient, then sensors measure something, it gets transferred into the system. Then you draw blood, send it to the laboratory. The laboratory has to send that information into the system as well. And then there's also another part of data which we haven't even touched yet, but it goes in the direction of natural language processing, because doctors make a lot of notes about the patient status. And that is something that you actually need some model to actually analyze that data. So that is one problem. And the other problem is that what we have seen many times is that there are clinicians or computer scientists working on a machine learning problem. But when it comes to deploying a model, and not considering all the other aspects you need for deploying a model, but just to combine those two expertise, to combine those two fields, I feel like is very challenging, because the computer scientists will say, oh, look at my AUC, it's perfect, 90%, 100%, it's perfect. But then you look at the data, or you look at the predictions, and you're like, okay, they don't make sense. But the computer scientist cannot say if what features make sense. He just sees, okay, we have a high feature importance, so that feature must be important. But then the clinicians know, okay, this feature got only measured because we already know that person had this disease. So I would say combining the two teams and domains is also another challenging part.
Okay, so it's quite complex. It's not as easy as we thought.
Yeah, and also something maybe that you could mention is that there's a workflow with doctors, right? They have to go to patients to look how they're doing. They already have very intense workflow and schedule in their head. So if you start to implement something new and it doesn't work, they're like, oh, I don't care what this is, it doesn't work. So actually you have to make room for doctors, for physicians to have time to work with that machine. And I think you have to include the clinician's workflow as soon as possible into model development.
Yeah, or you can do something to replace them.
Yeah, I don't think you can replace doctors anytime soon. I don't think so.
Well, let's see what ChatGPT can do.
Yeah, well, there are so many things that for example, if you have a patient and you have to do an examination, how do you want AI to do the examination for you? Because the doctor, we need to touch the patient, you need to feel, we need to see the patient. That is not something AI can necessarily do, but AI can support us in some tasks.
Yeah, that's quite interesting. Thanks.
Yeah.
Any more questions to Hua? if there's no more questions, then we will do the following things. So right now we will activate the